Hi, I'm Emma, and welcome to my channel. In the last video, we downloaded some basic code to our pushbot and got it driving. But I asked you to type in a bunch of code to get it to work. Let's take a look at what all that code means. In this video, we'll be talking about variables and how they work. When software programs run, there are a lot of bits, literally, of information to keep track of. For example, even in our simple tank drive program, we had 2 motors to keep track of and 2 numbers representing the motor powers. All of this information is kept in the robot's memory, but it would be bad if we just tossed all the data into the giant bag like a big bag of Legos. It would get mixed up and confused with all the other numbers. So instead, we keep it organized in memory using variables. You can think of a variable like a cardboard box with a label on it. Each box has 3 things. It has the kind of data it can hold, it has a size, and it has a label or name. Let's first talk about what things we can put in this box. Guess what? It turns out computers are really good at storing numbers. Shocking, I know. So it might not surprise you to know that most of the things that go in the box are some form of number, even when it might not seem like it. First off is integers. These are whole numbers with no fractional decimal point. Then comes the decimal numbers. These can have a decimal point. Then there is a type called a Boolean. These are true or false values, yes or no, on or off. If you're wondering why they're called Booleans, it's because they're named after George Boole, who introduced this type of logic. Even though we say true or false when talking about them, computers actually store them as numbers, 1 for true, 0 for false. But what about letters, like the text that's on screen right now? Well, computers store those as numbers too. We just assign a number to each letter. Fortunately, you don't have to remember what these numbers are. You can just type letters in and the conversion is done for you. The important thing to know is that a word or sentence is actually a sequence of characters, instead of just one number. Programming languages call this a string. You can store a single character in a variable, but a string of characters is actually a form of our last variable type. The last kind of variable type is an object reference. This is still a number, but it's a special number that holds the location of a compound structure in memory that we call an object. We'll talk about objects a lot more in a later video, but for now, know that an object reference is not really the object itself, but rather the address of an object. Let's talk about references a little bit more for just a moment, because it's a concept that beginner programmers can get tripped up by. Imagine that you're visiting a fancy party where they have a coat check. You step up to the counter, hand them your coat, and they hand you a little ticket with a number on it. You put the ticket in your pocket and head on into the party. Later, when you want to go home, you show up, hand them the ticket, and they go and retrieve your coat. Now, what if you could somehow write a different number on your ticket? Well, you would get someone else's coat. Your coat wouldn't disappear, it's still there, but your ticket now points to a different coat. So, the ticket is just the address of where to find your coat on the rack. Object references are just like this. They hold an address of where to find an object in memory. One additional thing about object references is that they keep track of what type of object they refer to. So, to use the previous example, if you show up at the coat check with your ticket, you know that what you'll get back is a coat, not a pit bull. In fact, the type of a variable is strongly enforced in Java. This means that if you declare that a variable holds booleans, then Java won't let you put an integer into that variable. It will always contain booleans for as long as it exists. Other languages like Python or JavaScript don't enforce this. Their variables are allowed to change types, so it can sometimes cause surprises if you're not careful. You could make a variable called distance to target, and it could contain the value true. The next thing we need to talk about is the size of a variable. Remember how I said that variables are like cardboard boxes? Well, just like boxes, variables come in a variety of sizes. They range from tiny boxes like a jewelry box to shoebox size to refrigerator box size. Some types, like booleans or characters, don't have any size options. It's when we get to integers we start to get size options. Here they are from smallest to largest: byte, short, int, and long. Int is short for integer, and you can probably figure out that short and long are short and long integers. Most of the time, int is the one that you'll be using the most. For decimal numbers, your options are float and double. Float means that it contains a decimal point that floats to accommodate the digits instead of being fixed at a particular point. Double is a float that can contain twice as many digits as a float. In the grand scheme of things, the robot has plenty of memory, so it usually won't matter if you use the refrigerator box size as value types. You can still put a ring in a refrigerator box. Just be aware that if you try to put a big value into a little box, you might end up cutting parts of it off. It's like trying to put a refrigerator into a jewelry box. You might fit a few screws or washers into the box, but definitely not the whole thing. The last and probably the most important part of a variable is the name. This is what helps you, the programmer, remember what you stored in the variable. So naming your variables is super important to avoid bugs and make the code easy to read. For example, if I showed you these two variables, L and R, would you know what they had in them? You might guess that it's left and right, but left and right what? Maybe left motor and right motor are easier to figure out. Obviously, simply making a variable name longer isn't always the best, because naming variables like, this is the DC motor on the left side of the robot, is going to make your fellow coders annoyed with you. Trust me, coming up with good variable names is one of the hardest things in programming. Java has a few rules on what you can name a variable, and then there are a few conventions that the Java community generally uses. Names must start with a letter, underscore, or $sign. You can't start a name with a number, but you can have numbers later on. So one button wouldn't work, but button 1 will. You can't use any spaces or other punctuation in the name. Java developers usually start variables with a lowercase letter and then use camel case from there. Unless the variable will never change, something that's called a constant. Constants are usually in all uppercase. These conventions aren't mandatory, but will help other programmers understand your code. Okay, so let's say that we've thought up a great variable name, we know what data type it needs to be, and what size it should be. How do we write that in Java? To create a variable, you simply need to define it. A variable definition in Java starts with the type first, then the name. So in our pushbot, this looks like double left power. Remember, type first, then name. So this is a variable named left power that holds decimal numbers that are double sized. But wait, the line doesn't stop there. There's an equal sign and then some other stuff. The part before the equal sign is the part that declares the variable. But a variable with nothing in it isn't very useful, so we immediately store something in there. This process is called variable initialization. For certain types, Java can and will automatically initialize them if you don't do it. So numbers like ints and doubles will be initialized with 0. For object references though, Java can't do this for you automatically. Remember our coat check analogy. They can't give you a ticket with a number on it already because that might be someone else's coat. So instead, object references start life containing a special value called null, which basically means nothing. If you try to use a reference that is null, your code will crash, so it's super important to put something meaningful in the variable first before you use it. Let's take a look at an example of this. Up higher in the file is the line private DC motor left motor. This is a little different from earlier because there's an extra keyword, private, before the type. We'll ignore that for now and leave that for another video. Next comes the type, DC motor. This means that this variable will contain a reference to an object of type DC motor. Finally, there's the variable name, left motor, and a semicolon. But wait, there's no equal sign after the definition, so that means that Java will automatically initialize it to null. If we don't do something to fix this, when the code reaches the loop method and tries to use it, the code will crash. Fortunately, we know that init will run before loop, so we have a chance to replace the null before that happens. And there, you'll see that we're asking the hardware map to get us a DC motor object, and then we'll store it in left motor. A single equals sign in Java is called the assignment operator. This is the way that we tell Java that it needs to take the value on the right side of the equal sign and put or assign it to the variable on the left. So before this line, the left motor variable has null in it. Afterwards, it will now contain a reference to the DC motor object. It will keep this value until we put something else in there. Later, we'll talk more about how to put a bunch of different types of variables together into a more complex structure called an object. But for now, I'll meet you in the next video where we'll talk about operators and what they do to variables. We already met one, the single equals sign, but there are others, some that are familiar from math class and some that might be new. See you there!